All right, so this is your weathering and erosion CER. So I'm going to read through the scenario with you. I'm going to give you some tips on what you need to do, and then you're going to fill it in right here, your C, your E, and your R, and then you're going to copy and paste all this information into your digital portfolio. So that should be all set up so you can see which slide that's supposed to be. All right, so let's go through the scenario right here. I know there's a lot of scary numbers here, and you're like, what does this chart mean? It's a lot simpler than you might think. Let's go through it. The Appalachian Mountains are a system of mountains located on the eastern coast of North America. So that's near us. It ranges from Georgia all the way up to Maine. So you can hike it. So they're composed mainly of marine sedimentary rocks, volcanic rocks, that'd be igneous rocks, and slivers of ancient ocean floor. So this mountain range once rose to at least 30,000 feet millions of years ago. That was really, really high up in the sky, but over time it's gone through weather and erosion. So scientific observations have concluded that the Appalachian Mountains are decreasing in elevation at a constant rate each year, right? So they're getting smaller and smaller and smaller, the top of them, at a constant rate, so the same amount each year. Table 1 depicts the estimated elevation of Mount Mitchell, the tallest peak of the Appalachian Mountains, at different intervals over the past 5 million years. So let's go through it. Right here, the present day is 2,037 meters. A million years ago, 2,067 meters. A million years before that, 2,097 meters. And then it just keeps going all the way up, right? You should notice a pattern at the constant rate. I'm not going to tell you what it is, but it's a pretty simple math problem to go back in time to see how much bigger it was, okay? Now, table 2, well, actually, let's go ahead. Write a scientific explanation that predicts its elevation in 8 million years in the future by describing the geologic processes that have caused the Appalachian Mountains to change in elevation. So again, we're not saying what is it like today. We're not saying what it was like 8 million years ago. We're saying what will be 8 million years into the future. If this trend continues, for whatever the trend is right there that you may have noticed, now I have to say what will be 8 million years into the future. That's what you're going to say into your claim. And then you need to explain it using evidence. So it says what has actually happened, right? And to cause it to get weathered and eroded away. Well, you can say for your evidence, facts that are within this chart. So you can reference this chart, right? And then you can also reference this chart. Let's go through it. The average yearly high temperature is 15.1 degrees Celsius. I know you're not super familiar with what Celsius is, right? We're all not. But there's one thing that you should know. The average yearly low temperature is negative. That's just the average, is in the negatives for Celsius. So what that means is that 0 degrees Celsius is the freezing point of water. That should be a big clue for you right there. If you look through your notes about all the different ways that things can get weathered and eroded, there should be something about the freezing point of water that should stick out to you right there that you can use as a piece of evidence. It also says average yearly precipitation. So there's a decent amount of precipitation that happens every single year. That should contribute to it. You might find another type of precipitation in your notes that you can reference as well. And then, of course,